Hello everyone. Today we are going to start with a different and a new thing, which is writing an investigative report. How do we write an investigative report? And first of all, what is investigative report? With investigative report is also known as investigative task, but the uses of investigative report or investigative task is in different is in all fields like such as chemistry, biology, physics, and many other things where you submit your experiments and your practical by doing such report, writing such report and giving in wherever you have to give that. Okay. So basically this report is the form, investigative report has different steps which we follow. Today we are gonna learn, I will explain what do we write in each step, what is the each step named. I'll also show you a small practical experiment which is known as looking at the sugar saturation point. So here we'll see that here we have sugar, three glasses of water, one is filled fully, half and small. So today I'll go explain you all the investigative report steps by conducting one small experiment so you know how do we write it. So let's get started. First of all, we start with the aim. Aim is also known as research question. Some places you write aim or some places you can write research question. Both is applicable. You can write both. So in aim you write a target or a purpose of achieving your goal. So what do you want? What do you want to find out and what you are willing to find that out? So basically in this experiment, if we want to write our aim, we can see looking to observe the saturation, to find the saturation point of sugar and water in different volumes of water. So we this is our aim, to find different saturation points in different volumes of water. Clear? So this is aim or known as research question. Then comes the background information. In background information, you basically write the definition, causes, types, disadvantages, advantages. So basically the fact which stays behind, which will never change, which you are not changing, no one is changing, but the fact is which will always remain in your experiment is that the saturation, what you can here explain the saturation point. What is saturation? So basically the word saturation means a proper limit, and when we say in grammar that I am saturated, means I can't bear that thing more. So write the definition of saturation, causes, types, advantages, disadvantages, everything you can do. So now here I can say one background information about this experiment is every molecule dissolves in water. Sugar dissolves in water till it reaches at the saturation point where no longer it can dissolve more. So we'll find that is the truth, that sugar is a molecule. So basically the fact or you add it in background information. Then comes hypothesis. Hypothesis is basically your prediction. What do you think your result will be? So your prediction of your result. Basically when you start writing your hypothesis, you basically start your sentence with I predict. You always start your sentence with I predict. So here in this experiment we can say I predict that if the amount of water increases, then it can hold more sugar and that increases the point of saturation. So now here you can see I have 3 glasses. If I add 5 spoon in this glass and 3 spoon in this glass, I think both it can saturate this glass, but this glass will need more amount of sugar, this will less, and this will need only 2 or 3 spoons of sugar, because the less the water, the less sugar it will need. Okay, now here you write the hypothesis. So this is my prediction. Your prediction could be anything else, but you write your prediction. In short, you write your prediction in your hypothesis. Then comes the variable table, where you make a table. There are 3 parts in a variable table. One is independent variable, second is dependent variable, and third is constant variable. In independent variable, you write one which we change. So what are we changing in this experiment? If we see, we are changing the amount of water, the water level we are changing, as you can see here, that each glass has different amount of water. Then in independent independent variable, we can say the amount of volume of water. Then we can, in dependent variable, we can say the volume which changes due to the independent variable. So because of independent variable, the dependent variable is dependent basically on independent variable. That is the saturation point. Each glass will have different saturation point because it has different amounts of water and it is different volume of water. So dependent variable is always dependent on independent variable. Now comes the constant variable. Constant variable is same in all times. So what is same in this experiment? The type of water, the stirring speed you can keep constant to find the accurate results. The type of sugar, I use this sugar, but if you are in a lab or doing a proper experiment, there is a sugar called laboratory graded sugar, you use that sugar. Then, so each glass has same type of water, so many things are constant. Okay, the thing you are measuring your time with will be constant. You can't be like counting one side and use the stopwatch. Two different methods. You keep everything constant to find the accurate result. Then comes the apparatus and materials. Apparatus is basically by which you conduct the experiments. So here you can see a different. I have spoon, glass, glasses. If you have you use stopwatch to measure the time. So these are our apparatus. But then other thing is materials. Materials is water, sugar, that is called materials. If you use another experiment, then chemicals, boroxide, sulfur oxide, any chemical which is you are using comes in materials, and the object by you conduct the experiment are apparatus. So you both list them down differently. Then the procedure. Procedure is basically the steps you perform to complete your aim. So when I have here, when I start my experiment, so I have different steps. First step is to fill the glasses. Second step is to start with the 150 ml of glass of water, where I start adding the sugar. I'll show you here. You can see I have added this much sugar. I will keep my sugar constant and I'll add this much sugar every time. So when I put this, I also measure the time. I start my time. When I did this experiment, each spoon took approximately 1 minute to dissolve the sugar fully. But as I told you, this is the home sugar which we use in cooking. But when I did this experiment, I had laboratory graded sugar, which helped me like 30 seconds before the experiment. So now you can see the sugar is fully dissolved. So I note my time. So this is the process. Now this step you repeat every time. So our second step was add the sugar, each amount, make sure the sugar is constant at each amount. Then comes another step where you note the time, you have the raw data in your book, you write all your raw data. Then you have to finish that experiment. You can't say that throw that water out. You have to say that decay this water into plant or use that into plantation, because it will definitely help plant because it has sugar in it. Okay, you wash your all apparatus and keep it back properly. So till start to end you have to give the full amount, full result, everything properly, that if a person reads your procedure, that can follow that procedure. Then comes the safety precautions. Safety precautions is basically, people always get confused in safety precautions. But safety precautions is always you write about your experiment. Your experiment should not spoil, and your safety, your personal safety. Okay. So when you say safety precaution, so in safety precaution, me and my experiment is the only thing you write about. So when you write an investigative task, write at least 3 safety precautions. As one I can tell you that do not drink or eat eat sugar. Now here, this is normal sugar. I know I have I have not touched any other chemicals. But whenever you are in lab or doing such experiments, do not eat or lick or do whatever which enters your body or with the materials you are using it. I know this is sugar, I know this is water, but please don't drink or eat while you are doing the experiment. Then we give a raw data table, apply the data you took performing the experiment. So basically while I was performing this table, I didn't start with writing this. We always start with the raw data, where I just write my raw data, what amount, what seconds I found that this is dissolved, and everything I made it into table. So that raw data table will now come here. You can edit later. Do not do this whole procedure while you are conducting your experiment. You just write your raw data when you are conducting your experiment. Then comes data processing. Find the average of your raw data. So here you have raw data table. You find the averages of amount. So for example, the 150 ml glass could be around 6 minutes 24 seconds, for example. So the average of it, you find the average and then calculate it. So also add the raw data table. So here you add your raw data table, you find the averages, make a graph of the averages, not the amount that you used in your raw data. You make the table of your averages and analyze that graph. So what do you think that graph looks like? You analyze it basically. Then comes the conclusion, where you put your where you say that did your hypothesis supported or rejected. Now let's come back to the hypothesis. Hypothesis is your prediction. As I told you, I predict that if the amount of water increases, then it holds more sugar molecules and that increases the point of saturation. Now when I see my graph over here, I will see that will that work, is that data matching to my hypothesis or not. If it's matching, I have to give a complete reason that why it is true, and if it's not if it's rejected, means it's not supporting my hypothesis, then I have to give again a good reason that why it is not supporting it. Yes, then comes the evaluation. In evaluation, you write your strength and your errors in your process. So while we wrote our process, so here we have to find the strength. So what were my strengths? That here right now, when I actually here I have used the cooking sugar which you have in the kitchen, but when I did this experiment, I used laboratory created sugar, which was very different when I used this and that sugar. That sugar dissolved so fast and this was not dissolving. It definitely took 6 minutes in one try, and that sugar was just like 30 seconds it showed it reaction. So basically my strength was I used that sugar, not this sugar. And then the errors which I made was that the stirring speed was not constant at each time. So there are some errors which I did in some strengths which were made my experiment stronger. So you list them down. At least write 3 errors and 3 strengths for complete information. Then you write your results. So answer to your aim. So result is basically your aim. You give an answer that what were you finding and did you get that or didn't get that. And at last you add your error table. Error table can be also added after evaluation. It's not compulsory to after add the results, but it helps you to complete that table properly. So here you write your error. So what was my error? I can say the constant speed of let's take that my speed was not constant at each time when I was stirring. Okay. So that is my first error. So effect of error in my in my experiment, in my procedure, was that I was not stirring the sugar. I changed my speed, I changed my way of stirring. So that made my experiment bit. The timings made the dissolution time made differ. So that all were the effect of error in my experiment. Then how can it be changed? It can be changed by when you use a machine or something, because we are human, we can't keep a same speed of stirring. well, I tried my best to keep the stirring speed same, but maybe it can differ sometime. And yeah, so when you write such reports, when you give your reports in a submission, you may mention that the speed you are stirring with, it's not constant, or the type, this whatever you think which is not constant, you please mention them here, because if you don't mention them, it may differ that this person tried their best and didn't succeed. So you have to mention that. It's okay you make mistakes, but you show that mistake that you made that. Don't say that you didn't make that mistake. Okay, so this is basically the investigative report, or also known as investigative task. This is the form which we generally do in IB. But yeah, these are the investigative reports and investigative tasks. We'll conduct more experiments with the investigative, show you the investigative report, and we'll do it together. I hope you liked my video and got to learn. Thank you.